Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our second PU Computer Science online classes. After completing the first program in our by using another method of deriving canonical SOP expression using algebraic method, we already completed one program. Now this is our second program. Or this program is also called as the method is also calling as the simplification of expressions. Okay, the simplification of expression. Now the question is the opening of the parenthesis x plus complement y, closing of the parenthesis plus opening of the parenthesis x plus z, closing of the parenthesis complement the entire function. Clear this point here? So first of all, it is the question. That means first of all we need to maybe complementation is not there. We need to use the complementation. So first thing, simplify the given expression using the appropriate theorems. We know that De Morganization law. Three important points are there. I think no need to recall, no need to tell about this one. Everyone know about the point of the process of De Morganization. Complement the entire function, change all plus to the dot, dot to the plus, and later next one complement the each of the individual variables. So all those steps we need to follow in starting step. With that we need to follow some other step also. Let's later words I will tell. Okay, what are the steps? That means maybe if any literal is missing, we need to use some other way. Correct? No, missing variable plus complement of the missing variable, and the third step, by removing the duplicate terms we get the desired canonical SOP form. Now the first thing, I am going to start from first line. Simplify the given expression using appropriate theorems or the rules. So opening of the parenthesis x plus for y, complementation is that. So I am using complement y by using the double complementation. Correct? No, kia for the y double complementation, for x just only one complementation is there here. This is the entire the complementation to the function, entire complementation to the function. So I am using opening of the parenthesis x plus complement of y, and later next one complement the entire function. Clear this one? Separately I am using for each function, and later next one plus sign is there. So I am changing such a plus sign to the dot sign. Then again I am opening the parenthesis. We know that no any complementation separately for the x and z, but the entire complementation is there to or for the whole function. So I am using opening of the parenthesis x plus z here, and later next one complementation to the entire function x plus z, complementation or complementation of x plus z here. Okay, and then closing of the parenthesis. Now also some plus sign is that, later words I am going to change. Clear this point here? Now also some plus sign is there in between our variable literals x plus complement of y and also x plus z. Later words I am going to change step by step. We need to use such lines. Okay, kya? And later next one, next line how I am using the opening of the parenthesis complement of x. Correct? No, why? Because for x no any complementation, just only the complementation is there for the entire function. So such complementation I am using complement of x. Now plus sign is there, so I am changing such a plus sign to the dot here. The De Morganization second step, change all the plus to dot, dot to the plus. Okay, so plus changing to the dot. Later next one complement to y is there, but for the entire function is there. So how we need to take the double complementation to the y. Clear this one? The double complementation, the variable complemented twicely, the variable name is the y. So double complementation, then closing of the parenthesis, and later next one plus sign is there. We already changed. Now also no any changes. So dot sign only we need to take here. here, clear this point. Then opening of the parenthesis, and for x and z, just entire function complementation is that. So complement x plus sign is that, need to change to the dot, and later next one complement of the z here. So clear this point here, complement of the z, and later next one how we are going to complete the next line. The next line, opening of the parenthesis, complement of x and but the double complementation to the variable y. So the double complementation to the variable y we can say as the complementary law, complementarity or complementary law here. So complement of a variable is complemented again, we get the same variable. So just only we need to take as the y, closing of the parenthesis, and later next one about our dot here. Then again opening of the parenthesis, complement of x and complement of the z as it is, we need to change. So in this line just only we completed the double complement to y is that we change to the y only, depend on the rules. By following the rules we completed this simplification, correct no kya? So this is our next line, and after that just only I am using some of the multiplication. Why? Because still here we don't know which variable is missing, correct no? So step by step we are going to use, we are using all those lines here. So before going to write or whatever we are going to write in our next line, now just I am going to multiplication in between the variables. So how I am using? So x, complement of x and complement of x, clear this point, complement of x and complement of x here. Later next one is the complement of x and complement of the z here, clear this one. So this is our first one, first line, complement of x and complement of x, plus later next one complement of x and complement of z, plus later next one after that we need to use as the y complement x, otherwise simply we can write in a correct manner as complement of x and y, okay. So the complement of x and y, actually how we need to take y complement of x, but in a correct rules I am going to use the variable in correct way. So I am using in this manner as the complement of x and y, plus and later next one is about our y complement z. So just only I did the multiplication in this line, clear this point here. So the multiplication, and after the multiplication we know that later words will get some other lines. So we know maybe if you are using 0 and 0, when you are going to multiply, maybe the complement of x or x value is equal to 0, 0 into 0 value is 0, or maybe x value is equal to 1. 1 into 1, the value is the 1. So what's the value we using for the x? Such value will get in answer, correct no kya? So just only I am using the multiplication. So after the multiplication how the value will get? The value is the complement of x here, the complement of x, clear this point here. So complement of x value is equal to 0. So 0 into 0, answer is the 0, or maybe x value is equal to 1, 1 into 1, answer is the 1 here. So just only I used here complement of x here. So clear this point here. So complement of x plus complement of x and complement of z as it is, no any changes, plus complement of x y as it is, no changes, plus y complement z, clear this point. So now we are in this line. Now this is our line. Now let's, after that we are going to follow the second steps. The second step is the, we can say as the wherever literal is missing, multiply that term with missing variable plus complement missing variable. Now I am going to use such method, such rules here. So the rule is the wherever literal is missing, multiply that term with the missing variable plus complement missing variable. Now when you are going to see this expression, we can say that here the first expression yz is going to missing, correct no? The y and z are missing here. So y and z. And when you are going to check this second thing, that means sure the y is missing here, and later next one in third expression the z is missing, and later next one in the last expression y complement z is that, that means the x is missing. So I return by using the using our circle. Okay, whatever the variable is missing here, I return by using the circle in this case here. So y, z and x for your easy method. Clear this point here? So this is now whatever the variable is missing, I am going to use the method. The method is multiply that term with the missing variable plus complement of missing variable. So complement of x, we know that y plus complement of y, correct? Now this value is missing here. So y plus complement of y and multiply, we need to make the multiplication dot here. So x and y and z, so this is called as the multiplication in between the variables. So y plus complement of y and z plus complement of z. Now just only we completed our first line, okay, the first line, and later next one I am going to use for our next expression. So complement x and complement z here. Now y is missing here, so and y plus complement of y. Now that means we completed in this line, okay. So this is our next thing, whatever the variable is missing, I completed by using the missing variable plus complement missing variable, but multiplied it, should remember this one, and plus next one complement of x and y. Now which variable is missing? The variable name is the z. So how I am using z plus complement of the z here, and later the lastly we can say that y complement z is there in our expression. Now the x variable is missing, so y and complement of z, and lastly x plus complement of the x here. So clear this point here. So x and the complement of the x. So this is our missing variable. We completed by using the multiplication and also the missing variable plus complement of the missing variable. Now just only in a correct manner how we completed in last class, okay, how we completed the first example here. So like that we are going to make some of the rules here also. So complement of x, y plus complement of x, complement of y. Clear this point here, how I am going to complete. So this is our whatever the missing variable is there, we already added by using missing variable plus complement missing variable. Now I am going to use by using the multiplication method. Why? Because I need to remove the duplicate terms. Maybe if any duplicate terms is there, I need to remove such a duplicate terms here. So before going to remove duplicate terms, we need to make the multiplication in a correct expression value, okay. So complement of x, y plus complement of x, complement y, and later next one z plus complement of z as it is. We know that we completed in first example also, same rules here, plus later next one complement of x, complement z, and later next one is the y. After that again complement x, complement z, and complement of y, plus after that later next one is about complement x, y, z, plus later, so complement x, y, z, plus after that complement x, y, complement z, okay, kya complement. Now also some of the expressions are there. So for some of the expression, plus y complement z, x here, plus y complement z, plus complement z and complement x here. So this is our next expression. By using the multiplication, we added in one expression the three variables. So clear this point here. So we added the three expressions here, and after completing, now I am just going to check whether any duplicate values are there or not. Clear? So before going to check the duplicate values, why? Because we know that this line, how we completed this line by using the multiplication. Now just only the first line, next the next line is the how I am going to write complement of x, y, z, okay, complement of x, y, z. Next line is the complement x, later next one complement of y, z. Clear this point here? Complement of x, complement of y and complement of z in this case here, and later next one is after that we are going to take as the complement x, complement z and the y plus complement of x and complement z and complement y plus complement of x, y, z plus complement of x, y, complement z plus y, complement z, x and lastly plus y, complement x, complement z and the complement x, just by using this line. Clear this point here? By using this line we completed such lines, just we made the multiplication in a correct manner, and after that we are going to use again such line here, and we are going to check maybe any duplicate values are there or not, and after removing the duplicate terms, so this is our third step. By removing the duplicate terms we get the desired canonical expression, and finally we will get the desired result or the SOP form by using the algebraic method. So the result is the complement x, y, z plus complement x, complement y, complement z plus x, y, complement z plus x, y, complement z. Clear this point here? So this is our algebraic method. By using some of the rules we need to complete such programs or the methods or the examples. Now let's the next definition, that is the POS. We know that the POS full form is the product of sum form, and for the product of sum form we using the formula, that is the pi or maybe pi capital M. The max term can also be considered with capital M or just only the pi. Now first of all the example, before going to know the example, let's the definition of the POS, product of the sum form. So when Boolean expression, we know example, Boolean expression x plus complement y, z, x plus y plus z, example for the Boolean expressions. So when Boolean expression is represented as purely as our product of max terms is called as the or said to be in our canonical POS form. Clear this point here? So we can say that when any Boolean expression is represented purely just for our product of max term, product of sum, that is called as the product of max term, is said to be in canonical POS form. Now let's one example. The example is the if x value is equal to 0, y value is equal to 1, z value is equal to 1, we know that the max term will be x plus y plus z, correct? No, x plus y plus z. But also for some variable I used complementation, and for some without complementation or no complementation is there. So we know the max term rules. So the max term rules, if the value of the variable is 1, then complement is added, otherwise variable is added as it is. Clear this point? Wherever the value or if a variable with value 1 should use the complementation. So this is the rules about our product, that is called as the max term, product of the sum. So I am going to complete for the value x is equal to 0, y is equal to 1, z is equal to 1 here. The value is the x plus y complement of y plus complement of z. Maybe the second example, x value is equal to 1, y value is equal to 1, z value is equal to 0. So first of all I am using x plus y plus z, and later next one it is not the last final result. We know that for x value is equal to 1, sure we need to use the complementation. Y value is equal to 1, we need to use the complementation, but z value is equal to 0, so no complementation. Okay, so the result is the complement of x plus complement of y plus z. Clear this one? Now we are going to solve some of the example or some of the problem about the POS expression. So before going to solve some problem from our product of the sum form, the first of all the truth table. So some of the steps I need to tell in our truth table. So the first thing, the truth table method to form POS expression. Truth table method to form the POS expression. So this step 1, prepare the truth table of input and the output. That means depend on the variable we are going to prepare the truth table. Maybe 2 variables, 20, 21, 01, 01. Maybe 3 variable, that means we can say as the 4041. Then later next one 2021, 01, 01. Maybe 4 variable, 80, 81, 4041. Third column 2021, last column 0101. So prepare the truth table of input and the output. Clear this point here? We know that in our POS the binary 0 is considered to form the POS. Clear this one? The binary 0 is considered to form the POS here. So prepare the truth table of input and the output, and later add one additional column, one more column we need to use here, the additional column for the minterm. Okay kya? Minterm for each row of the table kya. So not just only the input and output, depend on the value, depend on the values we are going to prepare the truth table. Also we need to use one more column, additional column. The name of the column is called as the max terms. Okay kya? So here I am using the value as the x plus y plus z. So maybe if any one value is there, I am going to use the complementation to the variable. And later the step 3, clear this point here, the step 3, in our step 3 how I am using, when the output is 0, take the max term. Clear this point here? When the output is 0, take the max term from that row and multiply the max term to form the POS. Clear this point? So all those steps we need to follow while going to solve our POS expression. First of all we need to prepare the truth table input and the output, and also we need to use additional column for the max terms here, and finally when output is equal to 0, take the max term from that row and multiply the max term to form the POS. Now let's one example we are going to solve. The question is the find the POS expression for truth table given below here. Clear this point? So this is the question. The question is the ABC. That means how many variables are there? 3 variables are there. If 3 variables, then sure we are going to use our 4041, 2021 and 0101. So 3 input will get here, and also this symbol. So what about this symbol? So this symbol is going to use, or the symbol of the max term, the symbol of the POS here, the POS, and in place of our 1, 2, 4, 6, I am using the value 0. In place of the 1, 2, 4, 6, I am using or taking the value the 0 here, and rest of the place the value going to use as the 1. Clear? In last class we know that some of the definition of the POS, product of sum, and we know the symbol for the POS, and also we completed or we know the definition of the POS with the example x is equal to 0, y is equal to 1, z is equal to 1, and x plus complement of y plus complement of z. We know the example of the max term here. Now let's one simple example for our POS by using the truth table. Okay. Now the question, ABC, 3 variables are there. Pi, that means sure we are going to construct POS expression truth table, and we using the value in place of 1, 2, 4, 6, the value is the 0, output as the 0. And first step 1, prepare the truth table input and the output. 3 variables A, B, C. 3 variables means in first column 40, 41. Okay, first column 4041, second column name is the B, 2021, 2021, and it is very necessary, very important to remember what's the variable names are there in question. depend on the question variable name we need to use in our answer. Okay, maybe XYZ, we need to change the column names. Maybe ABC, we need to use the name as the ABC. So ABC name, and in our second column 2021 2021. In last column, the name of the column is the C 01010101. Okay, so total octal table 2 to the power of 3, that is equal to 8 rows here we need, but going to start from 0 to 7, that is equal to 8. Now after we need one more additional column, correct? No, the additional column, that is the result column, and maybe in question some values are there 1 2 4 6. In those place we need to use the value 0. Okay, now in our first place it says 0. I am not using the value. The value I am going to use as the 1. We know that the differences between SOP and the POS. In SOP, binary 1 considered to form the SOP, but POS binary 0 is considered to form the POS. So in place of 1 I am using the value 0. In place of 2 I am using the value 0. In place of 4 the value 0, and also lastly place of 6 the value 0, and in rest of the place the value 1. But in our SOP, maybe if in any question maybe the values are there, in place of such value I am using the value 1, and in rest of the place I am using the value 0, but it is reverse of the SOP, should remember it here. So maybe if any numbers are there, in place of such number we need to use the value 0. In rest of the place the value need to use as the 1. Clear this one? And later whatever is there I am going to show the values here properly. Okay, so the 0 value, wherever the value 0 is there I am going to use, and like that after completing the fourth column, the last column also I am going to use, and such column name I am using as the max terms. Okay, the max terms, and in case of the max term we know that how we need to use A plus B plus C. Why? Because wherever the value 0 is there, no complementation. If the value of the variable 1, then complementation we need to use. Okay, yeah, so A plus B plus C. Later next one, A plus B plus complement of C, A plus complement of B plus C, and later next one A plus complement B plus complement C. Later next one complement A plus B plus C here, and later complement A plus B plus complement C, and later complement A plus complement B plus C, and finally for everywhere the value 1 is there. So there is no any doubt how we are using complement A plus complement B plus complement C. Okay, now we completed the last column by using our truth tables. Okay, we completed each and every columns by using our truth table here. Now lastly I am going to use the POS form here. So we know that in our POS the binary 0 is considered to form the POS. Binary 0 is considered to form the POS. So first of all, to construct the POS form I am using A plus B plus complement of C, and later next one A plus complement of B plus C, and complement A plus B plus C here, and complement A plus complement B plus C. So this is the last final result about our POS expression form. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.